How do engineers analyze circuits with multiple branches, loops, and components? Instead of guessing where current and voltage go, engineers use two powerful rules that work in almost every electrical circuit. In this video, we'll learn Kirchhoff's current law and Kirchhoff's voltage law, the foundation of circuit analysis. Kirchhoff's laws are two fundamental rules used to analyze electrical circuits. They were developed by German physicist Gustav Kirchhoff and remain essential tools for electrical engineers today. These laws help engineers understand how current and voltage behave in networks containing multiple branches and loops. The first law is Kirchhoff's Current Law, commonly called KCL. It states that the total current entering a junction must equal the total current leaving that junction. In other words, electric charge cannot accumulate indefinitely at a node inside a circuit. The second law is Kirchhoff's Voltage Law, or KVL. It states that the sum of all voltage rises and voltage drops around any closed loop must equal zero. Together, KCL and KVL provide a complete framework for analyzing most electrical circuits. KCL is based on the conservation of electric charge. When current arrives at a junction, the charge carriers cannot simply disappear or be created from nothing. Therefore, every ampere entering a node must eventually leave that node through one or more paths. KVL is based on the conservation of energy. As charge moves around a closed circuit loop, energy can be gained from sources such as batteries and lost across components such as resistors. The total energy gained must equal the total energy lost. These conservation principles are not engineering approximations but fundamental laws of physics. Because electrical circuits obey conservation of charge and energy, Kirchhoff's laws work reliably across an enormous range of electrical systems. Imagine a road intersection where vehicles arrive from several directions and leave through several exits. If 100 cars enter the intersection every minute, then 100 cars must also leave. Otherwise, cars would continuously accumulate in the intersection. This idea is very similar to KCL. Now imagine hiking around a mountain and returning to your starting point. You may climb uphill and then descend downhill, but after completing the full loop, your total change in elevation is zero. This is similar to KVL because energy gained and lost balances over a complete path. These analogies help transform abstract equations into intuitive concepts. KCL describes balance of flow, while KVL describes balance of energy. Engineers use KCL extensively when analyzing current distribution in parallel circuits. Whenever multiple branches meet at a node, KCL allows engineers to calculate unknown currents and understand how current divides between different paths. KVL is commonly used when analyzing voltage distribution in series circuits and closed electrical loops. Engineers can calculate unknown voltages, determine component behavior, and verify circuit operation using voltage loop equations. Modern circuit simulation software relies heavily on Kirchhoff's laws. Whether designing a smartphone, power supply, communication system, or RF circuit, engineers use these principles daily to predict and verify circuit performance. Suppose you are troubleshooting a circuit board and discover that current entering a node does not match the current leaving it. This immediately suggests either a measurement error or a fault within the circuit. KCL becomes a practical diagnostic tool. Similarly, if measured voltages around a loop do not add up correctly, engineers know that something is wrong. KVL helps identify wiring mistakes, damaged components, or incorrect assumptions during analysis. These laws are used in everything from household electronics to satellites and communication equipment. Although they appear simple, Kirchhoff's laws form the foundation of professional circuit analysis throughout the electrical engineering industry. So today, we learned the two fundamental rules of circuit analysis, Kirchhoff's Current Law and Kirchhoff's Voltage Law. Together, they help engineers track current flow and voltage distribution in almost any electrical circuit. In the next video, we'll explore ground and reference concepts and understand why voltage measurements always need a reference point. If you found this useful, like the video, subscribe, and follow for the next lesson.